All right, let's get started. Hey, and welcome to another episode of Get Swifty. Today we're talking about structs and enumerations, and next time we're talking about classes. Um, so let's just dive right in. First of all, we start with enumerations. So let me just quickly um, explain what enumerations or enums are in the context of Swift. So basically, you would use it to create your own kind of type of value, right? So most of the time, if you have like an enum in a different programming language, they're simple structures, right? Um, but with Swift, they put a lot of different functionality into an enumeration, so you can do all sorts of things with them. Today, we're not going to talk too deep about enums. If you're interested in what you can do with enums, just check out the official Swift documentation. But I'm going to show you the basics. So, first of all, if you remember from the previous lessons, we always had like some sort of function here um, where we had like some switch case uh, inside, and remember we could also have like if else blocks instead of switch cases if we wanted to. But basically, it looked something like that, right? Where we had like, okay, we're getting some string in as an argument, then we're switching over that and make a decision depending on what case it is, right? So if we just take the example from the very first lesson with the media types, right? Um, we can actually build a nice case where I can show you why enums are actually important here. So let's just return something. It doesn't really matter what it returns in that case, right? We just want to check out um, how that works. So, all right. Of course, it also needs a default because we're passing in the string and the compiler doesn't really know how many different cases there are. So there got to be a default because the user can put in Bob and then it never will go in here. So I want to just don't return array. Let's just do that. You can say not handled, whatever. All right. So we've I've talked about it a little bit, but what you see here is we have a function. You get in a string. You could also get in an integer or whatever. The problem here is if you have a switch inside and you just take a basic data type here, the compiler really doesn't know how many different cases there are going to be. So you got to have like a default value. But also a problem here could be that someone punches in musics for whatever reason, maybe a spelling mistake, or movies, or show. Like I did that here so you can see it, right? So if you put something else in, then our cases here it will also always end up in the default. So we don't really have control um, over the quality and to make sure that we're always handling the right case here. That and where we cannot make sure that errors are going to be reduced. So for that we could use enums, right? So within enum we can define our own data type, which we can use. So what we could do here is we could just say we define an enum called media type, and then in here, and this is the notation how it works, you can have different cases, like music, movie, show, book, and you see, like we have music, movie, show, book, not shows and movies or whatever, or books or whatever. It's just like really have music, movie, show, and book. So what does that give us? It gives us that we can check in our switch case instead of like on a string directly here. we can check on music, movie, show, and book on those cases. So if we would rewrite that method, now we could copy that. Let's just call that new. And then here for type string, we wouldn't say string, we would actually say media type. That forces the API caller to actually that forces the API caller to actually go. I'm sorry, I'm getting notifications here. Forgot to turn them off. Okay. To actually pass in one of those enums, right? So we got to change our code here. What we can do now is we can say media type dot music, and then we made sure we handle that case here. What you also could do is, you see, I wrote media type before with the dot annotation. Actually, Swift knows what kind of enum it expects here, right? So we could actually just access that directly here without actually writing media type before. So we can say just movie, and here we can just say show, and here we can just say book. All right, so that's a pretty cool way to actually make our function call more type safe. We can see our compiler here warns us and says default will never be executed. And I've said before, if you pass in simple data types like a string or an int, it doesn't really know what, like, all the cases, right? But because we defined the switch over media type, right? It knows in the enum media type there's only 4 different cases, so there's actually only 4 different cases in the switch here. So it says us like this default is never going to be executed because you make sure through your code that this cannot be anything else than those 4 cases. So we can get rid of that. And you see, we like our functions get more type safe when it comes to like those arguments where you pass in like a defined data type, your own defined data type, right? And you make sure that the API caller actually cannot mess up here. Like that's just not possible, and that's great. So another cool thing is sometimes what you want to have is an enum, and in that enum you want to have a case, and that case value expects or can have its own value, right? So just to rephrase that to make it a little bit easier, is a general powerful feature in Swift when it comes to enums is that your enums can have values assigned to them, and that's kind of cool, right? So if we again look at the previous lessons where we had the switch cases with the conditions in there and things like that, sometimes you might want to have that handled in your enum. Not really the condition, but you really want to have sometimes a value on your enum case, and you want to check on that value. So let's just create a new enum, and we call it mood type. And then in here, we would have like a case which is happy, and we have a case which is angry, and we would have like a case which is sad. And now we could say, for example, our case angry, we want to know how angry are you, like from a scale to 1 to, from 0 to 10, how angry are you? So we can say level, and this is just my argument name here, int, right? So that allows the user to have angry and pass in a value if he wants to, right? And we can do this with integer, we can do this with strings, right? Like this is how you would put the possibility to the API caller to actually pass in a value and store it for that enum case here. We get rid of that test here, So if we just write another function up called get mood status, for mood type, and we would return the same thing as before, just an optional string, and then we would switch over mood. And then in here, we can just say, for example, our simple happy case is return happy, happy, happy. And then we would have our angry case. And then we can see, let's just go back. We can see here angry level int, right? So we know, okay, it expects some sort of integer. So we can do angry, and then we could pass in like a 5 here. But that doesn't make sense because we want to have a condition here in that case, right? So what we actually want to do is, and that's pretty cool, we want to say angry, and then we would say want to say let level, and then we want to say where the level is, I don't know, smaller than 5. And then we could have the same case with where it is bigger, for example, than 5, right? And with that, you can play. Let's just quickly go into and see what that means. So what we did here is we're saying, okay, if we go into our switch and we run into the case of angry, we check here if there is a value stored inside. If yes, we pull it out and put it into that constant level, and then we can do conditional checks on it, right? Or you could access it or whatever. And that's how you would do it. So here we just return not so angry. And here we just return don't come close. Whatever. And of course, if we just want to handle a regular angry case without respecting the level, we can do that as well. And we can have all cases in one switch statement as well if we want to. So here we can just switch it up a little bit. Cool. And in the end, I think we have one more, which was our sad. So we can have sad here. And our default goes away. And sad would return. Aww. All right. So this is how you would actually access stored values inside of an enum. Let's just run it real quick and see what's happening here. Oh yeah, we actually got to call it, right? So get mood status 4, and now you can actually see how you would pass that in. So it knows it wants a mood type here. So again, we can just say dot, and let's say angry, and let's say 10. And then we can execute them, and we should see, poof, don't come closer. So that worked for us, right? So this is how you would access values inside of an enum, how you pass in an enum as well as a value, right? So that's with that you pretty much set when it comes to enums. Just a little bit to recap. When you're using condition that conditions in a switch statement. Now I got it. Took a little bit. When you're using conditions in switch statements, just please remember that Swift is actually checking from top to bottom. That means if you have like multiple cases of angry, and it jumps into, it's hard to explain, right? Anyway, let's just say those conditions are different. Let's not say this is like smaller and bigger. Let's just say those conditions are not mutually exclusive. Then Swift would, if that case is true, and that case is true, Swift would run first into that and then exit the case, the switch, right? So you gotta when you structure your conditions in a switch statement here. So one last thing before we go into struct is a small fun fact. Actually, optionals are implemented as enumerations. It has three cases. It has none, some, actually two cases, none and some, right? So none is clear. None is just nil. It's just nothing in there. And some means whatever value is inside of the optional. That's what some means. So it's basically like an any. It's generic. Um, so yeah, that's just a fun fact on the side here. So yeah, to recap, enums, pretty cool way to create your own kind of data type, to use them in different conditions. You can actually switch over them. You can iterate. You can do all sorts of things. So if you're interested in more of what you can do with enumerations and how you can really go crazy on them, just check out the official Swift documentation about enumerations. So next part would be struct. Okay, so a struct is basically a complex data type in Swift because it can contain multiple different values. So what you can do then, if you have a struct somewhere, you can actually create that struct and fill it with values, so with information, and then pass it around in your code. That's basically what the idea of a struct is. So how do you define a struct? A struct is simply defined by the keyword struct, and then we can give it a name like similar to classes, and we were going to talk about classes in the next video. But here we just define struct car, and our car has different values, right? So here we gotta know what is the manufacturer, which is a string, and we need to know what manufacturer it is. That's the reason why it's not an option. So model, which is also a string. We gotta know what kind of car model it is, and of course the horsepower, which in this case would be an int. So let's just compile that. So you might recognize that the compiler is not complaining about that piece of code here. And you might think, why isn't there an initializer? Doesn't don't that there has to be an initializer? No, there doesn't have to be an initializer because Swift makes it super easy for you to define a struct as it is creating a so-called member-wise initializer under the hood. So a member-wise initializer is, let me just quickly read you the definition. The definition is the easiest to understand. That Apple has an amazing definition for that. They probably better explain it than I could do it. So it pretty much says, unlike a default initializer, the structure receives a member-wise initializer even if it has stored properties that don't have default values. The member-wise initializer is a shorthand way to initialize the member properties of new structure instances. Initial values for the properties of the new instance can be passed to the member-wise initializer by name. So that basically means I can instantiate our car struct, and because of the member-wise initializer, we already know what kind of values it needs, and we can see that here it wants manufacturer model horsepower. And that's clear to the compiler because you defined it that way, and Swift does the member-wise initializer. So we can just hit cool, return, and then we put in the manufacturer, we can put in the model, and we can put in the horsepower. And we can see if we compile that, the compiler is happy with that. So memory-wise, initializer, pretty cool thing. So how do we actually access those values? Well, let's just print out the manufacturer. So we can just simply say favorite car dot, and then we have all the access to the properties here. So we can just say manufacturer, and that's it. This is how you would access values inside of a struct. Properties, I mean. Sorry. An interesting thing about structs, and I've talked about that in the introduction of structs, but if you assign a struct to another struct, yeah, what would happen, right? It's the same thing if you would think in Java, if you have a class. You have a class and you do something with it and you assign it to a variable at some point. What happens? You have a reference to the original object. So with structs in Swift, it's a little bit different. In there, what Swift does is if you assign your instantiated struct to something else, what happens? Swift does a so-called copy on write under the hood. So copy on write means basically that Swift just copies your data if you try changing it instead of creating a complete true copy of that original. So that's the big difference. So you always have a copy to write. You're never operating on the original object. Like you're just manipulating copies of the original and just changing the data on them. That's what you're doing with structs, and if you reuse them and change them at some point, that's important to know. So let's just visualize that. So we have another cool car, and that can be that can be a Porsche, and our model would be a 911 GT3 RS, and we have 550 horsepower on that. So we have another cool car. So what happens if we do make a copy? Let's just try that out. Var copy of car equals other cool car. All right. So we should actually see, yeah, we got the same car instance here at this point. So we got a copy of actually this one here. So if we would say print copy of car manufacturer, right? And we print that out here, here as well, and then just run it again. We should actually see it printing out Porsche for both of them. Don't let me hanging. Oh, that's of course not right. Of course, both are going to show Porsche now. So let's just change the horsepower on the copy. So copy of car dot horsepower equals 2000, and then if we print out copy of car again, and we print out the original, we should see the values should actually be different. And that's what I wanted to show you with that. Yeah, here we go. So we're printing both out. It didn't change the value on the original, right? We have a copy with the new value here. So that's really, really, really important to understand, to remember. So the last piece before I want to conclude today is that you can actually define functions in structs here. So, and a function in a struct would be called a method here. So we say struct car new, and in here we have our regular, our regular variables, our manufacturer and our model. Yeah, that was smart. And we have like some horsepower on it. And now we can define a method in here. So we can say func description, which would just give us back like a description of our car. So it returns a string. And in here we can just simply say return, and then we can say manufacturer, and we can say model, and we can say with horsepower, and then we should be good here. Yep. So let's just create a new car. So let's say new car equals car new, and then we bring in, and then we have like, I don't know, only two L's, but it's an A3, and I don't know, this one has 120 horsepower. And now we want to just print that out, so we can just say new car dot, and then we see it gives us our method here, description, and if we run that now, we see we get that string back. And to better see that, just print it out real quick, and we should see that down here. Please. Yep, there you go. So this is how you would define and call methods inside of a struct. And with that, I know today is just halftime, but there are a couple of things I got to take care of. So I'll see you next time, and we're going to talk about classes. So stay tuned for that, and I wish you all a great weekend.